Hi students, welcome to Knowledge Platform's Mathematics video series. In this video, we will learn how to solve a quadratic equation in one variable by factorization. We shall look at two different scenarios, when c is not equal to 0 and when c is equal to 0. Let us first look at the case where c is not equal to 0. In this case, if we find two numbers r and s such that r plus s equals b and r times s equals ac, then the quadratic equation can be factorized into two factors. Let us look at an example to see what this means. Say we have the following quadratic equation, 3x squared minus 7x minus 20 equals 0. Mapping this to our standard form, we see that a is equal to 3, b is equal to negative 7, and c is equal to negative 20. The challenge is, are we able to find two numbers r and s such that r plus s gives you negative 7 and r times s gives negative 60? If we try to solve this as a pair of simultaneous equations, we end up with another quadratic equation to solve, so that is not the way we want to go. Instead, we need to do some quick mental calculations in our mind and try various combinations of r and s. For this particular example, we end up with r equals to negative 12 and s equals 5 relatively easily. Now that we have worked out r and s, we can express our quadratic equation in this new form. Notice that all we have done is to break up the linear term into two new linear terms, which must add up to the original linear term. So here, negative 7x has been broken up into negative 12x plus 5x. This allows us to factorize the first two terms and the last two terms like this, which will yield x minus 4 for each pair, so that we can bring out x minus 4, leaving us with 3x plus 5, and this will give us this final form. Once in this form, finding the values of x becomes easy. When you multiply two numbers and get 0, what does that tell us? It tells us that at least one of the terms must be equal to 0. Think about this statement for a moment and convince yourself that this is true. So, that means that either x minus 4 equals to 0 or 3x plus 5 equals to 0. Now, for the first case where 3x plus 5 equals to 0, we get x equals negative 5 over 3. And for the second case, when x minus 4 equals 0, we end up with x equals 4. Therefore, our solution set is just negative 5 over 3 and 4. Now, it may be easy to solve using this method if the values of a, b, and c are relatively small. But if the values are large, it may be difficult to mentally find the values for r and s. For example, can you try to factorize 20x squared plus 12x minus 216 equals 0? Here, a is going to be 20, b is 12, and c is negative 216. We will have to find values for r and s such that r plus s equals 12 and r times s equals to negative 4320. It will not be easy because you have to try many combinations of numbers. Given this situation, what can we do? We shall use what we call the cross multiplication method. To begin, we list out the three terms of the equation in this simple table. These rows here will contain the factors that we want to find. Listen very carefully to the following procedures. In step 1, we need to factorize 20x squared into two terms and list them out here as two rows. Since we know both our factors are linear and each one must contain an x, we can safely put one x here and one x here. As for the coefficients, let us try 2 and 10. Verify that whatever you put here must multiply to give 20x squared. In step 2, we do the same thing to negative 216, meaning to factorize negative 216 into two terms and then to put the factors into the two rows. Let us try negative 4 and 54, since these numbers multiply to give negative 216. In step 3, cross-multiply these terms like this and write out their products in the last column. we end up with negative 40x and 108x. This step is the reason why we call this method the cross multiplication method. In the last step, we have to make sure that these two products add up to the linear term in the quadratic equation. If they do, you have completed the factorization. Evidently, for this case, negative 40x and 108x do not add up to 12x. So that means that we have to find other values for the factors. To do that, let us list out the factors for 20x squared. These are going to be listed here. Next, we list out the factors for negative 216. Can you tell which combination of numbers will allow us to get 12x in the last column? Put your mental calculation skill to the test. After a little while, you will see that the correct combination is this: 4x times 5x and negative 12 times 18. So that the table will be filled up in this manner. Since negative 60x and 72x add up to give 12x, our factorization is complete, and the factors are 4x minus 12 and 5x plus 18. Therefore, our equation can then be expressed as... Do you see the power of this cross multiplication method over the previous method? In the previous method, we have to find r and s such that r plus s equals 12 and r times s equals negative 4320. This is difficult since we do not know what values r and s can take. But with the cross multiplication method, our choices are narrowed down to these factors of 20 and negative 216, which allows us to arrive at the factors much more easily. We have now looked at the first scenario, when c is not 0. Let us now look at the second scenario, when c is equal to 0. When c is 0, our quadratic equation reduces to this: ax squared plus bx equals 0. Now, you may feel the urge to divide throughout by x, because that will give us a linear equation which is simple to solve. However, let's see what happens when we divide throughout by x. The resulting linear equation has only one root, while we know that a quadratic equation has two roots. What this means is that in the process of cancelling out x from both sides, we have lost one root. Therefore, this is not the way we want to go. The proper step is to factor out the common quantity, which is x, so we end up with x times ax plus b, like this. And then we use the same argument as before, that since their product is 0, either one of them must be 0. So, we have either x equals 0 or ax plus b equals 0, in which case x becomes negative b over a. Therefore, our solution set is going to be 0 and negative b over a. Now, one thing we observe here is that since x has been factored out, one of the roots will always be 0. This is an important concept to remember. Let us try a quick quiz. The first step is to bring out the x so that we end up with x times 8x minus 3, like this. Then, either x is equal to 0 or 8x minus 3 equals 0, which will give us x equals to 3 over 8. Therefore, our solution set is 0 and 3 over 8.